Okay, we have here today another interesting integral. We've got the integral of 3 to the x times 3 to the 3x times 3 to the 3 to the 3x dx. Okay, now the first thing I noticed is what we have here. This is actually really similar to a problem I did recently where everything was basically the same, I think, except we had e's instead of 3's. So it's actually going to be really similar because when we do this, we use this property for any value. Like if we have an a value, we can actually rewrite this as e to the ln a. And so in the case of in our case of 3, we can write 3 as e ln 3. And that's really how we get these general formulas over here to the right. So when we have the derivative of something with a constant base like a to the x, we have this formula that's going to be just the natural log of that base times the same thing, a to the x. And for the integral of a to the x, that's going to be really similar, except this ln a, kind of the same thing, but the ln a just ends up in the denominator. So now getting back to this integral, what I want to do is let's do a u substitution on this. We could do this two ways. That would be fine. We could do our u substitution for 3 to the x, but I think what I want to do is let's just do our u substitution for this whole thing right here. So going ahead with this, we're going to have u equal to this whole thing, 3 to the 3 to the 3 to the x. So now we can go ahead and take a derivative, but what I'm going to do for this derivative, I'm going to use this formula over here, and in order to think of it in the same form, our base a is going to be 3, and then for our x, you can think of it like doing a substitution in your head, but we're going to have this as the whole exponent. So using this, what's going to happen is we're going to have this ln 3 in front, and then we get back to a to the x, but that's going to be the whole thing. So we're going to end up with 3 to the 3 to the 3 to the x, but now we need chain rule on this piece right here. So when we do that, something really similar is going to happen. We're going to use the same formula again. We're going to get another ln 3. We get the whole thing back, 3 to the 3 to the x, but then we need the chain rule again on just this 3 to the x. But now that's exactly like this formula over here, right? So then we're going to have another ln 3, and then the rest of it's just going to be a to the x or 3 to the x. Then we'll have a dx on the end, but now let's clean this all up as we've got 3 copies of ln 3. So what I can do for this, rewriting our du, I can write this as ln 3 cubed, and then we just have all these other terms here. And now at this point, what you might notice is that we have everything right here. This is exactly our whole integral. Now the only thing is we don't have this ln 3 cubed part. So what I'll do is rewrite the integral, and I'm just going to create this part here in front, but I don't want to change it, so I'll divide it off in front. So we're actually just multiplying by 1, and then let's just copy all the rest of this stuff down. But now we have this set up where this is exactly our du value. This is exactly identical, so we can go ahead with this substitution now. So we'll have this 1 over ln cubed in front, but now the whole integral just becomes du, or 1 times du. So now we can just go ahead and integrate this. We'll have this constant value in front, but we integrate 1, we just get u. And so all I need to do is back substitute with this thing in order to finish this thing off. Okay, I ran out of space, but now we can back substitute in order to finish this thing off. So I just need to plug this in. So for my final solution, we just get 3 to the 3 to the 3 to the x over natural log 3 all cubed, add a plus c, and that's it. Okay, there you have it. Pretty strange problem with a lot of 3's in it. Okay, that's it for today. Thanks everyone for watching. Have a good day.